Let's prove the product rule. I'm going to be using this notation right here. F times G prime is equal to, and what I'm going to do is I'm going to use the definition of the derivative to compute this proof. And that is f of x plus h. It is the limit as h approaches 0 of f of x plus h times g of x plus h minus f of x times g of x. All of this over h. At first glance, it doesn't seem like this doesn't help us at all. So what we're going to do is we're going to add and subtract f of x plus h times g of x, and that is going to allow us to do some algebraic manipulation which defines this proof. So continuing on, we write f of g, f times g prime equaling the limit as h approaches 0 of f of x plus h times g of x plus h minus, and I'm adding now, f of x plus h times g of x. What I'm going to do now is I'm just going to add it again, which would make this segment here 0. F of x plus h times g of x. I'm just adding 0. I'm not doing anything really. What the hell? Hold on. There we go. And now minus this part right here, minus f of x times g of x, and this whole thing over h. Okay, so I'm not really doing anything naughty right here. I'm just adding a 0, and that's perfectly fine. So adding a 0 to an equation is perfectly fine. So what I'm going to do is I'm going to manipulate this little change that I made. So what I'm going to do now is I'm going to factor this. The limit as h approaches 0 of f of x plus h times g of x plus h minus g of x, and all of that over h. I'm using limit properties to split this segment of the proof up into two parts, plus the limit as h approaches 0 of g of x times f of x plus, that's a bad x plus h minus f of x, all of that over h. And you can pause this video right now and you can calculate this out, and you'll see that this is the exact same thing as this. So continuing on, f times g prime. What I'm going to do now is I'm going to put f of x plus h in front of this expression. I'm going to put g of x in front of this expression, and that is also perfectly fine if you know your algebra, and I hope you can see this. See that? F of x plus h times g of x plus h minus g of x over h. This right here is the exact same thing, plus the limit as h approaches 0. I'm doing the exact same thing right here, g of x times f of x plus h minus f of x, all of that over h. And now to the next part of this proof, f times g prime. I'm going to split this up into 4 limits. This will be, well, let me do that in another color. This will be one limit, this will be another limit, this will be a third limit, and this will be a fourth limit. And that is perfectly fine if you know your limits. This is just a limit property. So what I'm going to do now is I'm going to write the limit as h approaches 0 of f of x plus h, that's this part right here, times, just going to put in a parenthesis right here, the limit as h approaches 0 of g of x plus h minus g of x, all of that over h, plus this plus right here is this plus right here, plus the limit as h approaches 0 of g of x, that's this g of x right here, times the limit as h approaches 0 of f of x plus h minus f of x, all of that over h. And now hopefully you can see what's happening here, and you should be, or I hope you are relating to the product rule as you see this happening. Because now as I take this limit right here, as h approaches 0, this h right here is approaching 0, that becomes f of x. And this is times this expression. And as h approaches 0, well, doesn't this look familiar? This is the definition of the derivative. So this is g prime of x plus, this plus right here, the limit as h approaches 0 of g of x, well, there is no h, so this is g of x, times this, not this, but this expression right here, and this is again the definition of the derivative. This is obviously f prime of x, and there you have it. This is the product rule.